Hello and welcome to today's lesson looking at density, which is in the topic the particle model of matter for GCSE Separate Science Physics. So in today's lesson what we're going to do is look at density by being able to define what density is and looking at how to calculate density. So in today's lesson, if we're successful and we learn in today's lesson, we should be able to define what density is, calculate density from given values and understand how the density of a substance links to the particle model of matter, which falls into the following part of the AQA separate science topic of a particle model of matter in the GCSE Physics section. So the particle model of matter was proposed by John Dalton in 1819. John Dalton proposed that all substances were made from indivisible spheres, which he called particles. Dalton then proposed that all solids had the same formation of particles, all liquids had the same formation of particles, and all gases had the same formation of particles. And this can explain many material properties easily. Now, Dalton proposed that solids had the following formation of particles, liquids had this formation of particles, and gases had this formation of particles. And together this was called the particle model of matter. But this particle model of matter has many limitations. It doesn't show the forces between the particles. Particles aren't actually solid spheres of the same size as shown in the diagrams, and the particles are always in motion and not stationary as it appears in these diagrams. However, the particle model of matter is very useful because it can explain many phenomena in the natural world, such as density. So the density is the amount of matter in a substance in a certain volume. So it's a measure of how much mass of material there is in a certain volume, or a measure of the number of particles in a certain volume, or a measure of space between the particles in a certain volume, or a measure of how spread out the particles are in a certain volume. Now, if an object is very dense, then it has lots of particles per unit volume, so there are small gaps on average between the particles in the substance. If an object is not very dense, then it has few particles per unit volume. If an object is not dense, it therefore means there's large gaps on average between the particles in the substance. So density is the mass of a substance in a unit volume. So we can calculate it with the following equation. Density is equal to mass divided by volume. Now if we place some units in there, the unit of mass is kilograms, the unit of volume is meters cubed, and the unit of density therefore is kilograms per meter cubed. Now you're expected to memorize this equation for your examination. This means you should be able to rearrange this equation to make mass or volume the subject as well as using it to work out density. So we can clarify that density is the mass of 1 cubic meter of a substance. So gold has a density of 19,300 kilograms per meter cubed. So it means that 1 meter cubed of gold has a mass of 19,300 kilograms. We can symbolize our equation with the following symbols: rho representing density, m representing mass, and v representing volume. So rho equals m over v. Now the unit of density can be written as either kilograms per meter cubed or kilograms to the meters to the -3. Now to work out your unit of density, it's worked out by dividing the unit of mass by the unit of volume. So for example, if mass was in grams and volume was in centimeters cubed, your unit of density will be grams per centimeter cubed. So the units of density are dependent on the units of mass and the units of volume. It's my advice that instead of trying to convert a unit of density after you calculate it, actually convert the unit of mass or volume beforehand to the values you need in your density unit. Now, as we mentioned before, because density is the amount of matter in a substance, and a dense material looks like this and a less dense material looks like this, it shows us that solids have a higher density than liquids and liquids have a higher density than gases, since solids have the most particles per unit volume and gases have the least particles per unit volume. You can also talk about it in terms of space between the particles. In a unit volume, gases have a greater space between the particles compared to solids, or you can mention in terms of how spread out the particles are. Solids are more condensed per unit volume, while gases are more spread out per unit volume. So just remember, solids have the highest density, liquids in the middle, and gases have the least density. Now, because density is the amount of matter in a substance in a unit volume, and matter comes from particles, technically a vacuum has a density of 0, as there are no particles in the volume at all on average. So here's an example question where you're asked to calculate density. So if the question says you have a mass of 6 grams in a volume of 2 centimeters cubed, what is the density of the substance? So the first step you do is you write out your equation, density equals mass over volume. Always write the equation out, you may receive a mark for it. You then substitute the values into the equation so the examiner can identify the fact you know which one is mass and you know which one is volume. So it's 6 grams over 2 centimeters cubed. You then work out your answer, it's 3 grams per centimeter cubed, and you give your answer with the right units and the correct number of significant figures. Now in the question, each value was given to one significant figure, so your answer is given to one significant figure. 3. Now, if a shape is regular or symmetrical, we can find its volume using an equation found in mathematics. So if it is a sphere, you can work out the volume of a sphere with the equation 4 over 3 pi r cubed, where r is the radius of the object. For a volume of a cube, it's L cubed, which is the length of the object. And finally, the volume of a cylinder is pi r squared times by h, where r is the radius of the object and h is the height. So an example question with this would be, if you have a mass of 20 grams in a sphere with a radius 4.0 centimeters cubed, what is the density of the substance? So as always, you write down the equation, density equals mass over volume. You then work out the volume of the object with the mathematical equation. It's a sphere, so it's 4 over 3 times by pi times by r cubed. You work it through and you get 268.08. Now never round your value till the end of the question. You then substitute those values into the density equation and you get your answer out to be 0.075 grams per centimeters cubed. Remembering to give your value with units and giving your value to the right number of significant figures. In the question, both values are given to 2 significant figures, so your answer should be given to 2 significant figures. So to summarize what we've learned in today's lesson, density is given by the equation density is equal to mass over volume. You should be able to recall and explain the different states of matter using the particle model and why you've got different densities according to the particle model. You should be able to draw and recognize simple diagrams to model the difference between solids, liquids and gases, and you should be explain the differences in densities between the different states of matter in terms of atoms or molecules. So if you've been successful and you've learned in today's lesson, you can define what density is, calculate density from given values, and understand how the density of a substance links to the particle model of matter. Hope you've enjoyed today's lesson looking at density in the topic the particle model of matter, and have a lovely day.